Hello, my name is Brian Blaze, and I'm here to talk to you about a project called Statistical Inference for Everyone, or Beginning with Bayes, where we envision a introductory statistics course from the perspective of probability theory as logic, or Bayesian perspective. And I'm envisioning this course as something that a non-major would take, someone like a biology major or physics or social sciences, psychology, and to be able to actually apply Bayesian techniques in that sort of environment. So probability is right up front in this entire project. And the topics are pretty typical for that. And then we get into applications of probability, things like medical tests, predicting weather, and these sorts of things. A few more tricky problems like the Monte Carlo problem and these sorts of issues. And then we get into the heart of the probability analysis in terms of model comparison. And this is the real strength of the Bayesian approach, or probability theory's logic, where you can do multiple hypotheses. And then we apply it to a number of different cases. And then when that model comparison goes to the continuous regime, then that moves right into parameter estimation, a number of the standard statistical tests, and so on. And that and where those come from, especially the role of the normal distribution. The chapters alternate between theory and applications, and then end with computer examples, which I'll show shortly. And the final parts deal with multi-parameter models, and which is multiple regression, linear regression, and so on, and Markov chain Monte Carlo MCMC techniques. So SIE comes with a number of functions, and here we're looking at the normal approximation and the student t-distributions for estimating the best true value for a series of data, essentially the sample mean, with a known deviation given. That allows us to use the normal approximation, and the disk plot allows us to visualize it with all the quartiles. And we can get credible intervals as well. When we don't know sigma, we have to estimate it from the sample deviation, and this line gives us a t-distribution with n-1 as the degrees of freedom, and then again the distribution plot, which lets us visualize more clearly the t-distribution and get credible intervals. And all of this is accessible to someone who is not particularly strong in mathematics. So focusing on visualization is the key here. SIE also comes with a Markov chain Monte Carlo engine. It's actually the MC Hammer engine that is open source. Here we're using just make up some data that have essentially mean 0. Go down to the linear model. So the linear model has two parameters, a slope and an intercept, and then we can specify our priors for that. I'm just using uniform priors. Again, we run MCMC, we get something that converges. We can run the predictions and see how the model fits the data. We can then plot the distributions. And again, all this is a wrapper around the more complicated syntactically MCMC engines. And so the point here is that you can make these things accessible to a more novice audience, and one that has not as much technical experience, and in a single class time be able to get them up and doing some simple MCMC simulations. Coming back to summarize, this project provides the tools, both the textbook and software package, for doing Bayesian analysis or probability theory as logic in an introductory setting, and tries to allow everyone access to the power of using Bayesian reasoning in statistical inference. Thank you very much.